The first physical property of the soil that we can measure that is based very directly upon texture and structure is the physical property of bulk density. Well, let's take a look at this term bulk and density. The term bulk is implying the whole soil. So bulk meaning the entire mass of the soil. The term density, well, if we measure the density of something, we're looking at how much that material weighs per unit volume. So weight over volume is how we measure density. Soils utilizes the metric system exclusively. So when we're talking about weight in the metric system, we utilize grams. We're talking about relatively small amounts of weight in this case, so we utilize grams. If we were talking about larger amounts of weight, we would be utilizing megagrams, or first kilograms and then later megagrams if we're talking about large volumes of soil. So we need to understand what a gram is. A gram is a very small unit of weight. There are 454 of these in 1 pound and approximately 30 in an ounce. So we're talking about a relatively small amount of soil if we're talking about a gram of soil. The unit of volume that is used for the purpose of density that we do in the laboratory is the cubic centimeter, or the cc. Now, I think most of us have encountered cc's or cubic centimeters when looking at vials and vaccines and injections and those types of things. Well, that unit of volume is the same that we're talking about here, the cubic centimeter. And the cubic centimeter is also the same as a milliliter. So the milliliter, which is 1/1000th of a liter in a standard unit of volume in the metric system, the milliliter for measuring small units of volume and the cc are interchangeable with each other, meaning that they are the same unit of measurement, just two different ways of expressing that unit. So bulk densities of soils are measuring the weight per unit volume of a soil. And I think you can see that the percentage of sand, silt, and clay, or the textural class of a soil, will have an influence upon the density of that soil. But also, what amount of and type of structure formation do we have in this soil? Because that will also have an influence upon the density of that soil. As structural units form, at least the more desirable ones, in a soil profile, they allow for more airspace within that soil profile, and therefore we decrease the density of the soil. When we're looking at bulk density of soils, we're going to be doing this on a dry weight basis, because there's no way to compare two soils and their bulk densities unless we remove that other variable, the water content that is being held in the soil. So bulk densities of soils are measured on an oven dry weight basis. So we're basically removing the water down to a certain known level by placing that soil sample into a soils drying oven for a specified period of time. That removes the water, and then we're left with just the soil itself, or the dry matter in the soil to be weighed. So when we talk about the bulk density of a soil, we're talking about taking a soil sample of known volume, drying it in an oven, weighing that soil, and then taking the dry weight of that soil and dividing it by the volume. And if dry weight is in grams and volume is in cubic centimeters, then the units on bulk density will be grams per cc, or grams per cubic centimeter. If we're talking about coarse textured soils versus medium textured versus finer textured soils, we need to take a look and think about an example of this for just a moment. If you had a volume of soil, let's say 1 cubic meter of soil, and if that soil were occupied by sand-sized particles, those are the larger sized particles, versus that same volume of soil being occupied by silt-sized particles, versus that same volume of soil being occupied by a clay-sized particle, which of those three soils do you believe would have the greater amount of mass or weight per unit volume? Would it be the sand, the larger size aggregates, or not aggregates but particles, the silt, the intermediate sized particles, or would it be the clay? Well, this often catches people by surprise, but as we increase the size of the particles, we are going to increase the density or the weight per unit volume. Well, if we're increasing the weight, the density, then that must mean we have what? More or less pore space in that soil. Pore space being the volume of the soil occupied by voids or not solids. Well, if the sandy soil is going to weigh the most per unit volume, then that tells us that the sandy or coarse texture soil must have a lower amount of pore space or pore volume per unit volume than does the silt, which is the intermediate one, or the clay, which is a smaller one. So there are really two ways we can describe this. As soil particle size increases, density will increase, which means that the volume of pore space must decrease. Another way of saying that is that coarse textured soils will have a lower amount of pore space than will intermediate sized silty soils, which will be somewhat less in terms of weight per unit volume. And then when we get into the finer textured soils, the clays, those that are higher in clay content, they will have a lower weight per unit volume or a lower density, which means that they must have a greater percent of their volume occupied by pore space than do the medium and or the coarse textured soils. So those two properties of the soil, the density, bulk density, weight per unit volume, versus the pore space, are inversely related. As bulk density goes up, pore space will go down. As bulk density goes down, pore space will go up. And that's a very important concept or relationship to remember, because it is only in the pore spaces that we can transmit water, that we can hold water, and that soil has the capability of holding water and releasing it to the roots of plants growing in that particular soil. What would be a normal average value for bulk density of a soil? Well, if we're talking about loamy textured soils, silt loams, loams, perhaps even sandy loams, and to a certain extent clay loams, what's a normal density range for these soils? Well, a normal density range would fall somewhere between about 1.4 and 1.5 for loamy textured soils. If we have soils that are finer textured down in the what would be the upper portion of the textural triangle, we would expect these soils to be from approximately 1 up to about 1.3. Very coarse soils, those high in sand, would typically have bulk density values from 1.5 on up. Now, there are going to be some things that cause variation in here. As we increase the amount of organic matter in a soil, we would expect the density of that soil to do what? Increase or decrease? So on one hand, we're saying organic matter increases, that's a solid. We would think that the density would be greater, but we need to understand that it's not, because organic material weighs a lot less per unit volume than does the mineral matter over here on the other side. So if we're putting some higher percentage of organic material in the soil, we are decreasing the amount of mineral particles in that same volume of soil, because there can only be so much solids occupying that volume of soil. That will cause the density, bulk density, to go down. So for any given textural class of soil, if we have a soil within a given textural class with a high organic matter content, we would expect its bulk density to be less than the same textural class of soil which had a low organic matter content. So probably the easiest way to remember that is that within a given textural class of soil, increasing the organic matter content will reduce or decrease the bulk density. From a practical standpoint, how do we use, or how would we utilize the information if we had it? In other words, if we knew what the bulk density of this soil was, what practical use can we make of that particular information? Well, realistically, when we're talking about bulk densities, we need to look at it from a standpoint of bulk density occurring at different depths within the soil profile and different locations within perhaps that field or within that given geographical area. If we know under ideal conditions, we have a soil that has a good water relations, good aeration, and we measure the bulk density of that, and it's in a given textural class, then we can compare other soils to that.